MicroPython here. This is ESP8266. This actually runs MicroPython. And this is a journey that I started at PyCon last year with the PyBay. It's a really interesting piece of hardware. There's a couple of drawbacks. The hardware is awesome, but it's not particularly cheap. And it's $50, which is really, really good price. But the thing is, this board is about $15 to $5, depending on where you bought it. And it runs MicroPython. And the ability of running MicroPython means that you can actually teach Python, which brings us as, well, turns out that I'm a Python instructor. And I want this chip to be able to run async I/O. Raymond actually told us about concurrency yesterday. He gave us an awesome keynote about how important is this. So I knew that this was important in general for the community, and it's very relevant if I can run MicroPython in MicroPython async I/O. So I get into other projects, and now there's the big IoT and theme flows and stuff like that. So what I'm going to show here is a little demonstration of how to run a little analog to digital here. It's going to convert the signal into different values. It's going to transmit that using wireless. It's going to connect to this cell phone, which is the access point, which is already my computer connected to it. So there's some connectivity between this board and this computer. And now, how do I talk with this guy? This guy is another board that runs also a version of MicroPython. It's a CircuitPython Express. And the question is, how do I make Mosquito, is a managed queue telemetry protocol, and how do we make everything working together? So let's take a look at the code. This is basically the setup. That's the client side that is running here in the MicroPython, connects to the wireless, opens a Mosquito writer, starts the sensing. There's an API in order to set up the different parameters customization that you need, because the ground is not quite ground, and in order to customize, you can have that. And also, that's another thing that is very important is, what values do you want this AD to send out? And I want a value from 0 to 1. MicroPython sends 0 to 1024. So I do a pre-conversion there, so I have the data normalized. And then I connect with the schedule sensor and send that thing through the MicroPython, and now is the workflow from the lower layers. Then it goes all the way back, gets to the socket into the computer. From the socket gets to the Mosquito. The Mosquito, I have a little workflow. So this is the theme flow framework. And it's very interesting how the theme flow framework works, because you send some output objects, output things, and you can create with some sort of functional programming, basically methods, all cascades into one to the other. So decode the signal, convert it into JSON, from JSON to something, and Python object, and now you have an actual event. That event, we do some parsing. In this case, we convert and normalize the 0 to 1 to a value 0 to 55, and then finally send that to the ring, which is an input thing. And that's the code that is gonna make this ring. That ring is this object, and I made all the drivers in order for this to happen. And that's the code that actually makes this into the async I/O schedule, as you can see there. And let's see if this works. This is the chip with the code inside. As you saw on the code, it's going to automatically connect as a client into the access point. And before we power this up, let's look at the actual data if we have something, because in Python, we program as we go, right? We test the code, every line that we are writing, make sure that we see the data is what we want, and then when we actually have the whole program, we make sure that things are gonna run because there's no bugs. We actually test every single thing. So let's see. I'm gonna activate the environment. So now is trying to look for data.
I'll hold the microphone.
Okay, so I'm connecting the battery into the sensor. And this thing needs to connect into the IoT. And as you can see, now I'm having signals. You saw before that this number should be between 0 and 1, and that's because the API. We said exactly that that should be the case. And now for the last part, can you, Marlene, please move the potentiometer a little so the signals, you will see the different values, they should be increasing. All the way up. Thank you so much.
It makes different colors.
Yay.
Yay! All right.
Thank you so much.